you probably were responsible or one of the team members to set up the $3 billion, Sanofi, vaccine greenfield site. Probably the largest. You are amongst the guys there. So, how was it to set up as large as greenfield site? It must have been completely automated. What was the kind of scale that they were operating?
Well, so the Sanofi site is actually a 120-year-old site, so it was not a greenfield site, that
Okay.
particular site. It's a $3 billion biggest vaccine site. I think it is 3 billion. I may have to go check on it. I put it on my resume, so it got to be. But anyway, so this site is a close to 1,000-acre site, and it's a huge vaccine manufacturing site. Oh, they are one of their biggest vaccine manufacturing sites. Within the site, they were building a $500 million new biologics building to increase their capacity. And it was one of those U.S. government-sponsored projects to build a new capacity in the U.S. Typically, I was not involved in the beginning of that site, so that's kind of a genesis when it comes to the pharma. Whereas I can talk about the $130 million site, steel plant site, that I was involved from day one.
Please go ahead.
I worked in a existing plant almost 10 years, brownfield site in an old steel plant. So I had a pretty good idea of what I wanted to do on a greenfield site. One of the things in any project, when you start doing a project, is what product you're going to manufacture. That's the basis for everything you do right after that. And this particular instance, steel making is there's two kinds of steel making. You have carbon steel making and stainless steel making. They're both completely different products. A melt shop that makes carbon steel making doesn't make stainless steel making. It cannot make those. But this company decided to do both in the same plant. So that became the basis for how we do. So there is a mechanical design aspect of it. So someone else was doing it. The different equipment they had to buy, different furnaces they had to buy, different power requirements they had to have for each one. So they were doing it. Whereas my job was more related to raw material moving through the plant, how we receive it, how do we do the conversion, what kind of automation we need, what kind of a data we need to collect. So we're doing a data mapping of the entire process. So at the beginning, you do that process, and then you work with the different suppliers. Steel making is almost a 200, 300-year-old industry. They're making steel forever. And so, you also look at the industry, what other companies are doing, and then you come up with a concept design. And then you go about and say, these are the different, I'm going to melt it, I'm going to refine it, I'm going to take the different impurities out, and then I'm going to cast it. And so those are the 3 or 4 different areas. And within each area, we started looking at what we want in terms of equipment. So overall, I also had a philosophy of what kind of a control system I needed. So I had some corporate standards written for each area. Say, I want this particular brand of PLC, this particular brand of human-machine interface. I want this particular SCADA system. And so those are some of my corporate standards. So that becomes a basis for any vendor to bid on the package, to provide a proposal for you. So, a plant like this, it takes almost 2 to 3 years to design, develop, get bid packages, and then use those bid packages to further refine your processes. In the meantime, you're working with your IT groups, your quality groups, to say, hey, I need this kind of infrastructure. IT, can you provide me this kind of a network, wireless network, whatever that is, servers and everything. Quality, what kind of a data that we need to collect, and how
Mm,
are we going to use this data? Work with your metallurgist. What kind of a chemistries we are going to make? How
mm,
can you predict when steel will be done? Can we
mm,
build some models for it? So all those things become part of it. So it is a complex process. And obviously, I'm not the only one in this team. And you surround yourself with a lot of smart people who know what they are doing, and then take the benefit of their wisdom. And my role, and then it becomes a more of a you're facilitating different the communications and ideas, and then also being pragmatic, what is possible and what is our capex needs and what is available. So you mingle all that, and then have a good project managers to help you, because it is a complex project, right? So
mm.
yeah, that
And
was my
therefore, what's the kind of outcome did you achieve out of this? Did you achieve the goal that you set out? And so, what was
yeah.
it like, and what were you really, proud about?
It was a $120 million product, and we did build it. And 15 years ago, it was one of the very modern steel making plant in the U.S. at the time. And we did make stainless steel and carbon steel. And the first time we made a stainless steel, it took almost like I would say 48 hours to make one batch of steel, whereas a carbon steel, every hour will make one batch. So you
Mm,
can see the complexity. There was a lot of learning, and also when we first started, our utilization rate was about 45%. A lot of learning, a lot of changes we had to make. We had some reliability, premature failure issues. So I had to adjust my head, and we had a lot of teams. One of the teams I was on was how to improve the caster reliability. I learned quite a bit, and we brought the efficiencies and to almost a 70% by the time I left the company. So it was when you see the product coming out, uh, it, it, that's one of those the best satisfactions you can get out of. It's like when I had my kids, that was one of the best joys you can have, and probably it's not as quite as that, but definitely it's a great achievement. You gain a lot of confidence. It's not a hard work. Like it's a 15-hour days non-stop for starting up a plant 6 to 8 months. You're using all kinds of hours. You're spending a lot of sleepless hours. But at the end, it's all well worth it. And I would say it's one of the very productive, efficient plants. I even took a visit 4 or 5 years later. Twice I actually took two different companies that I worked for on a plant tour of it. I had a good relationship with the company. I haven't done a tour in 5 years of the site, but it's one of those family-owned companies. They welcomed you back. So I was grateful to take a tour back. Some of my people in my team to show them what a digital plant will look like.
okay.
And, so yeah.
So when you build the nature of what Sridhar talks about, the digital factory, a completely greenfield project like the steel plant that he talks about, what was interesting for me to observe and look at is the multiple functions that he had to coordinate and understand. So it's not just about his area and role of saying, let me build a digital factory. I am a manufacturing specialist. Let me now bring my PLCs and SCADA systems and all other kind of human interface devices into the plant. He had to work with the IT team, understand help them understand the networking principles that was required. He had to work with the metallurgy team and actually say, you know what, if you're really looking at what kind of a data do you want from these devices to decide on your quality, what kind of data should I be capturing? The ability to think multifunction, to be interdisciplinary, to learn from other industries and apply them is a key skill that I think is very, very important. And as you build new ideas, new factories, new thoughts, the fact that you need to interact and coordinate with multiple functions and help them understand your vision, seek their support, and ensure that their work becomes efficient is something that, as an engineer, as a business head, as a as an ongoing person who's actually building your career, these become very important. And if you are in a siloed, closed thinking job mode, you will never be able to expand and build large digital transformation projects like a digital factory.